So today I'm going to present a topic that in my list for a very long time, which is called recommendation systems. Let's go. Have you ever think about those problems, those issues that I mentioned here? Like first, how could Spotify know what songs you like and put them in your weekly recommendation list? Or how does Facebook decide like what kind of posts they want to feed you in the new feeds? And how a YouTube channel could recommend videos that you never watched before, but you like it very much. Or now, how could TikTok always feed you with new short videos that you just cannot stop watching it? Those questions that I mentioned above all shared some similar characteristics with each other. Like first, they are targeting at a user's design contents, and then they're extending the user's screen hours on their own application as much as possible. And also they are charging no fees from like basic users by adding ads between videos, music, and posts. There are two algorithms that I want to mention here. The first one is the most basic one, which is collaborative filtering, and the second is right now most popular one using using deep learning. For the CF, um, the basic logic was um, there's one type called user based. So it looks users who share the same pattern with active user. And another one is called item based. It sort of build a item metric relationship, and it sort of refers the taste of current users by examining the metrics and matching that user's data. There are three major types of collaborative filtering. The first is called memory based. It's kind of the combination of user based and item based, right? So it approached user data like the user rating data to compute the similarity between the users and the items. And the second is called model based. In this approach, models are developed to use different data mining, machine learning algorithms to make predictions about users' rating on those unrated items. So they are using like Bayesian's network clustering models, latent semantic models. As for the hybrid, it kind of overcomes the limitation of native CF approaches and add prediction performance. So it's kind of the combination of the two that I mentioned above. However, it also has largely increased the complexity and the cost of money. Okay, the interesting one. Deep learning. Like everyone right now is trying to put deep learning in their application. So why not? As for deep learning in the recommendation system, it can model the nonlinear interactions in the data with the nonlinear activation. Also, it could efficiently learn underlying explanatory factors and useful representations from the input data. Last but not least, it has high flexibility in terms of the number of available APIs nowadays. Okay, there are three major types that I want to introduce here for deep learning recommendation system. The first one is called a multi-layer perceptron-based recommendation. As you can see on the right, it is a feed-forward natural network with multiple hidden layers between the input layer and output layer. So it's kind of a stack layer of nonlinear transformation. It's kind of the basic, the basis and the foundation of numerous advanced approaches, and it's widely used in many areas. The second that I want to mention here is called autoencoder-based recommendation. There are three layers. The first is called encoder. Second is the decoder, and the one between is bottleneck layer. It is a unsupervised model attempting to reconstruct its output data in the its input data in the output layer. So generally, the bottleneck layer is used as a feature representation of the input layer. The third one that I want to talk about here is called convolutional neural network based recommendation, aka CNN. Okay, CNN is basically a feed-forward neural network with layers and a polling operation. It can capture like global and local features, so it could significantly enhances the model's efficiency and accuracy. It's very powerful in processing unstructured data like media's like images, text, audios, and videos. Okay, after introduce these two basic, uh, you know, most used algorithm logic for recommendation system, I want to mention here about how YouTube deal with this. There are two natural network for YouTube's algorithm. One is for candidate generation, and the another is for ranking. As you can see on the right, so the candidate generation network significantly decreases the number of videos and make a group of the most relevant ones from a huge group. And the candidates are the most relevant to the user, which whose grade we are predicting. And the second step, the goal here right now is to analyze all of them more carefully so that they can make the best decision. And this task is accomplished by ranking network, which can assign a score to each video according to a desired objective function that use data describing the video and also the information about users' behavior. So, so that after this two step above, they can make video recommendation from very large group of video, while still being certain that this small group of them are personalized and highly engaging for the user. And there are my references for the lecture or for the presentation. Sorry. So, in the end of this presentation, I want to ask you guys a question, which is that in what degree do you think that the recommendation system in the social media affect your life? Is it in a good way or is it in a bad way? And in terms of like the recommendation systems, it for me it actually I think I believe that it affects the human society more than lots of us can imagine. Because right now most of the products are free, so we use it like we took it for granted. But like what we don't know is that what they are doing behind the scene for our using our data, right? So there's a line from a movie called Social Dilemma that I like very much. It's called "If you are not paying for the product, then you are the product itself." Yeah, I think that's it. And I will cover more if I have the chance. More details in terms of how the algorithm really works. Thank you.